Alrighty, so we did get that connectivity problem solved. It was in fact a licensing problem, and the issue there is that we started out with a 60-day license, and we've kind of just reached the end of that, I reckon. So a lot of you guys have been having the same problem. So what I'll do is, after this little session here in our lunch break today, I will email you out the new license.
New license.
Okay, so yeah, that's going to help a lot.
We have to.
Yeah, you have to install a new license. Okay. So basically, that's what I just did here. Where are we? Here we are. So you may recall, request systems license, add terminal. We're going to put this new license in, and we should be seeing license successfully added and problem solved. Okay, yeah, Juniper are very devious, I think, in the way that they go about these VMXs. Everything works, like you can configure everything, and everything configures up beautifully. Just that all of your links run as slow as an old dog, and you can't even ping, across from one end to the other without even that failing. So yeah, so the license fixes everything. Let's take a look at our license while we're talking about that. Let's do a show system license, and this is our license now. We've got this 12 months license that expires next year in October. So the 60-day license is replaced with this one. Problem solved, right? Okay, this is the old license that we had before, so 60-day one, which is replaced with this new one up here. All good, and BGP looks a lot happier. Right. Excuse me. Alrighty, so let's go and check what's going on with our VPN. So we've got a peer between our PE and our CE. Let's see what we are receiving from our CE. Let's just check what's coming in across that session. So we're going to do a show route receive protocol BGP, and we want to check it from our peer, which is the 10.0.10.2. What's coming in? So here we are. This is what's coming in from the CE. We've got all of these. We've got these routes here. These are all of our static routes that we set up earlier on in actually last week's session. So there's 172.10, and it's .0, .1, .2, and .3. They're full static routes, and we've got our direct interface routes there as well. Loopback, we've got our physical interface and our loopback interface. Now the reason that they exist is because of the export policy that we have applied. We're exporting both our static and our direct routes. And that's all we're getting. That's it. Okay. So I want you to notice something here. I want you to notice that the next hop is the physical interface on the CE end of the link. So that's the CE's physical interface as the next hop on that route. Okay, now let's see, what are we advertising to our route reflector? Let's see what we're advertising to the route reflector. That's our peer. So we're going to do a show route advertising protocol BGP, and we're going to look for 192.168.5.2. Okay, so we are advertising the routes that we have received. Okay, the routes that we have received, we are advertising to our route reflector. Alrighty, So this is what we received from the CE, and here's what we're advertising to a route reflector. I want you to notice something here that I want you to think about. We've got the next hop that we have received from the CE 10.0.10.2. But when we re-advertise the route, the next hop has changed. The next hop has changed to self. And the question is, why is that? Why is that? And the reason that that's interesting is because we do not have a next hop self policy configured. Okay, if you want to check that, show configuration, policy options. So here's our policy options. We've got our export policy that we have applied. All right, so we're exporting direct routes, we're exporting static routes. So we do have it configured, but we don't have it applied. We don't have it applied. In actual fact, I could deactivate that next hop self policy. And in fact, I'm going to deactivate it just to kind of see what happens here. So policy options, let's go up there, let's go show there. Alright, so let's just, in fact I'm going to delete it altogether. You don't really need it. I'm going to delete this. So there we are, it's gone. Commit and quit. It's gone. Alright, so show BGP. Everything's established. And let's take a look at our advertising protocol. There we are. So we're still advertising next hop as self, right? And yet I've totally deleted the next hop self policy. We hadn't applied it anyway, so we weren't using it. So I've deleted it, but still the next hop is self. How is this happening? Okay, why? Well, and why is that an issue? Well, because as you may recall, when you receive an eBGP route that is then re-advertised to an iBGP peer, the default behavior of BGP is it does not update the next hop attribute. Okay, and yet here, yes, it is updated. It is updated. So why is that? Well, the answer really lies in looking at what we're receiving. Let's go to the other end over here. I'm going to do the show route receive protocol, BGP, and let's take a look at 192.168.1.1 and see what's coming in here. Oh, I don't see anything. That's established. Oh, I know why. Guess what? I put the wrong address in, right? Should have put the route reflector in there. There we are. So we're getting into our VPN table. All right, we are importing the routes from the CE at the other end. So what we're getting is the customer's route from the other end, the other site, which is what we want. We want that. So that's good. That's that. But now we've got this other table here. Nothing in there, nothing in there. But look at this. Now we've got our BGP layer 3 VPN table. Look what's coming in here. you've got these routes. Okay, so what are these routes all about? What's going on with that? Well, let's just go back to our P1, do a show BGP summary. It's not looking very happy, is it? Okay, so what these routes here are, right, they are the layer 3 VPN routes coming in. So they are the SAFI 128 format right there, okay, where we've added in this information here. Okay, this 192.168.1.1 column 13. That is what? That is the route distinguisher. Okay, so what we've done is we've added the route distinguisher to the routes. So essentially what this PE device does is it receives the routes from the CE, but then it has to convert the routes into the layer 3 VPN format by adding the route distinguisher to the routes and then re-advertise the route. So in the process of that, what it actually does is it regenerates the route and then re-advertises the route. So because it had to regenerate the route itself into this new format, then when it re-advertises, it re-advertises as a new route, and therefore it is now the originator of that route. So therefore the next hop becomes self, because the route is regenerated into this new format with the route distinguisher. It has to add the route distinguisher into the route. Okay, so in the process of regenerating the route, it also changes the next hop to itself, because it is the new originator of that route, of that new route with the route distinguisher. So we don't need next hop self to arrive at a next hop self outcome. BGP's up now. So it is in fact this parameter right here, this BGP layer 3 VPN configuration parameter that is causing the route to be regenerated and re-originated from the PE with the route identifier, with the route distinguisher added in, which is right there. Now we've already configured that in a previous lab. Okay, so what happens is the route is advertised, it's received into this BGP L3 VPN table at the other end, and then this PE will use the route target to filter the routes and put those originally advertised routes into its VRF table for that VPN. So there we are. Just something of a little bit of interest. I'm sure you've been wondering why that is. I'm sure you've been wondering about that. So I thought I'd just answer that question for you. Okay, so there we are. Let's see what we are receiving from the other end, by the way. Show route receive protocol from 192.168.5.2. Yes, we've got to put the BGP in there. We need that. So we are receiving the static routes from the CE at the other end. So there we are, 172.10. We've got 4, 5, 6, and 7, which is the other site's static routes. And we are also going to be receiving those same routes with the route distinguisher added into our BGP L3 VPN table. So they actually arrive in this table first, and then they are redistributed over into our VPN instance, which is the inet.0 table on our VPN instance, and filtered into that table by the route target. Okay, so it's a route target that filters them. So we receive them here, into BGP L3 VPN with the route distinguisher. They then filtered by the route target and put into the VRF table VPN 1-A as the original routes. Okay, with the route distinguisher removed. Okay, so that's what we would be expecting to see right there. What we need to do is to see if our VPN is actually up and running, we need to do a ping test, an end-to-end ping test. So we're going to ping the CE at the other end. Let's just double check what that information is that we need to be pinging. We're going to be doing a show route table CE1 dash, what is that? I think that's 2 of them, or is it? There it is there, CE1-2. So I'm going to be pinging the loopback interface 192.168.11.2. Okay, so let's do that. 11.2. We're going to source that route from our own CE loopback interface 192.168.11.1. We need to reference the routing instance, and the routing instance is our CE1-1. We don't have a route to the host. Why is that? Okay, we lost our BGP link. That's why we don't have a route to the host. So BGP does have to be up for this to work. It is a little bit, it's up there, but it's not up here. Yeah, so I see we've had 14 flaps since we got started, so it's not all that stable. Alright, so let's wait for that to come back up, and then we'll be able to do a connectivity test, and that should work after that. Okay, that will verify our VPN. The next thing we want to do, so kind of while we're waiting for that to come up, how's it looking? Oh, there it is, it's up now. All good. Let's just do that connectivity test again. Still not coming up. So if the other end is up. The other end's gone down. Okay. BGP. Problematic. Okay, so while we're waiting for both ends to come up, what we want to do is we'll go ahead and we'll go and set up the peering between our other VRF and our CE. So let's get that up. Alright, so we'll do, we're going to peer between our, this is our VPN B, we're going to set up now. So we're going to peer between our PE and our CE1-3. We're going to do that on MX1. So we're going to go -B, protocols, BGP. Alright, so what's our first job? I'm going to create a BGP group. I'm going to call it my external group B. this will be an external group. We need to give it a neighbor. So looking at the lab diagram, the address is 10.1.11.2.
Yeah. Not 10. 10.1.
10.1. Sorry, yes, that is 10. You're right. Yeah. Thank you. 10.1.10.2. Yeah. 10.1.10.2. Thank you. Okay. The peer autonomous system is 65102. 65102. What have we got so far? Okay, type external 65102. We need to add the AS override statement so that we advertise the routes into that autonomous system. Okay, that's good. We'll commit that. Actually, let's just go up and set up the other side. Then we'll commit it all together. CE1-3 protocols, BGP, let's create a group. Type is external. Let's give it a neighbor. So 10.1.10.1. Here autonomous system is 65512.
Is it still my external group B? Okay.
Yeah, look, I've just added the B on both sides. I know the lab leaves the B off.
B off, yes.
It's just the name.
Okay.
You can call it anything you like.
So, is it okay to off the B?
Yes, you can leave the B. You can leave the B. You could actually call it Mickey Mouse. It would still work. Okay, it doesn't matter. It's just a name. Yeah. So it's just so what you would normally say if you were doing this in an operational environment, you would probably give it the name which related to maybe the actual the other end, what the other end of the link actually was. So maybe it was a location, maybe it's a peer between Hong Kong and Singapore. Maybe it's so you might call it the Singapore link, for example. So you give it a name that sort of had a relevant meaning to what it was, what its purpose was. Yeah. Okay, and what else are we doing here? We are going to put an export policy on that. Let's take a look at what we've got so far. Type external export policy, a peer autonomous system, and a neighbor. Let's see if that's coming up. Not yet. That's looking better. So our that has now come up. Sadly, our peering with our route reflector is not so good. Let's hope it comes back up. Excuse me. Okay, so there we are. We've got that bit sorted. let's go and do the other side of our VPN. So we're going to do VPN 1B protocols, BGP. Let's create a group. And the type is external. Let's give it a neighbor. So let's take a look at the lab diagram here. So PE to CE1-4 is 10.1.11.2. Peering autonomous system is 65102. And we need to add the AS override on that. Okay. So there we have it. Let's go and set up the other side of this peer. CE1-4 protocols BGP. Set group. It's an external peer. So let's give it a neighbor. It's 10.1.11.1. Peer autonomous system is 65512. Okay, and we need to export our static and direct routes. So let's do that. Export policy. Right there. There we are. So that looks like. Okay, let's commit. Oops. And see if that comes up for us. Still waiting. And that's now come up. So that's all good. Okay, so we've got those established. Still having problems with our route reflector here though. Let's come up nicely on the other end, and still not come up on this end. To get the VPN working, you've got to have established on both sides, otherwise it is not going to work. Yeah. So as we've noticed before, BGP is not the fastest protocol in the world, and we're just going to wait for that. We have to wait for that to come up, otherwise we can't test our VPNs. We want to test our VPNs. Okay, that's what we want to do. And we want to check what we're advertising as well. Well, we can check what we're receiving from our peer. We can check that. So let's do that. And we want to check what's coming from the CE on 10.1.10.2. So there we are. We are receiving those routes, the 172.11 static routes 0, 1, 2, 3, plus the directly connected interfaces. Those directly connected interface routes, so they're all there as well. That's good. Let's see what we are advertising to the route reflector. So there we go. We're advertising both of the VPN sites. So there's customer A with customer A's routes, and we are now also advertising customer B here with VPN B. So advertising both. Next hop self. So far so good. Still don't have BGP up on the other end. Okay, so that's what we would be expecting to be advertising. We can check what we're receiving from the peers at the other end. Just move this a little up. So we are looking for 10.1 to 11.2. So there is our static routes and our direct interface routes coming in there. 172.11, 4, 5, 6, and 7 with the interface routes. Next hop being the physical interface on the CE end of that link. Okay. Well, we can't retest our VPN until we get both sides established at once. That one's up. That one's not up. Yep, so we can't do a ping test until we've got everything established on both sides at the same time. Yeah, so there are obviously a few connectivity issues, across the topology here, and so we've got 17 route flaps since we've gotten started here. It's gone up and down 17 times, is what that's telling me. Why is it doing it? Good question. Usually it's something to do with the maximum transmission unit settings on the interfaces, so that's just something I'm going to go back and check out to see that they're all the same. They have to be all the same right the way through, otherwise you can get these problems with BGP. In that it comes up, it goes down, it comes up, it goes down. It just kind of cycles through. Alrighty, so we're going to check that. Make sure all that's working. We'll take a break. We're actually coming into lunch. We'll take a break. I'm going to email everybody that new license, so you can install that. Once we get that in, it should solve some problems. We'll take a break. We'll come back and hopefully we'll catch both sides being up at once, and we can do this connectivity check. The next thing we're going to do is we're going to implement route target filtering, and just a little bit of an overview of what that actually is. with what route target filtering does, let's do a. So, what route target filtering does is it instructs the route reflector to advertise only the routes that match a route target. That's different to what happens by default. So by default, the route reflector advertises all the routes that it knows, and then the route target is used to filter the routes into the respective VRF tables.
So it's just the new control.
So that's the default behavior. So the route reflector advertises everything, but you can use route target filtering to tell the route reflector what route targets you have, and then it will only advertise the routes that match the route targets. So instead of advertising absolutely everything to the PE, it will only advertise the routes that match its route targets. Why is that good? Well, because it ultimately advertises less routes, so you're consuming less bandwidth with all these route advertisements going right across the VPN. We are talking about VPN scaling, right? Things that make it more efficient, and that's just one of those things. So we're going to look at that. I want to get these, kind of show these VPNs up and running if possible. Still don't have BGP up there. Actually lost it at both ends now, so we'll take a break and we'll come back and hopefully we'll get it up and check these VPNs are working, and then we'll get in and look at our route target filtering.